Okay, good afternoon, everybody. Thank you for inviting me to speak. Yeah, I'm very locally. I'm up in Tampines at the United World College. It is the second campus in Singapore. The Dover campus is closer to here. I think Dover's been going 40 years, and our campus is relatively new, six or 7 years old, and I've been there 5 years. And I was very lucky to join the school with empty spaces, so I was able to create all our own spaces from scratch. I'm going to talk to you a little bit about the past to start with. Some of you may remember some of these pictures. Maybe I'm just too old. Or mums and dads might talk about these kind of spaces. These are early maker spaces, believe it or not, 100 years ago. This particular place is a metal workshop, or in the US often known as shop. And we have another example here, known as woodwork, wood shop. And some of you might have some probably not the greatest experiences with some of those spaces. Other examples are technical drawing. Okay, those kind of spaces mainly for students maybe with a bit more of a brain, maybe math, science, can count, can measure things. And then we have other spaces such as home economics, where we have the introduction of food and things like these. So these are early maker spaces really in my mind. And often gender bias as well, as you see, girls and boys being separated, and yeah, watch out the US at the moment. We've got some of the more modern sort of maker spaces now. It's sort of at university level or technical colleges. A lot of these spaces are a little bit different, still quite similar, still quite a lot of similar equipment. And you'll see here a wood shop, here's a metal shop, and you'll see examples of graphic design using CAD/CAM capabilities to do your digital working environment and digital manufacturing, all in one place. And then we also have the more modern style food and nutrition kitchen. These kind of spaces really allow students to have those hands-on experiences, understand the technicality of it, and actually get a real understanding of what it feels like in the real world to do some of these hands-on practices. Then we have the cool things happening over there in the US, D-School, with moving whiteboards to create collaborative spaces. Big talk about these kind of spaces. Schools quickly getting rid of normal wall spaces, cork boards, and having pretty much the whole space built with whiteboards to enable that collaborative discussion. And we've also got things like moving furnitures. And these are sort of things that pop up quite frequent in those maker spaces. Furniture that you can collapse, move around, you can create very quickly walls, communication spaces, presentation stage, or a wall, or all these different things. So these are quite sort of newish things that people seem to be talking a lot about. So the maker movement is something that, for me, I've never really heard about it until about 3 or 4 years ago. Lots of books coming all over the place. At United World College, we ran the first international DT conference. It was a very big conference with about 170 people. We had the MOE from Brunei, Singapore, Malaysia present, and a wide range of teachers from different parts of the world. I'm Swiss, believe it or not, and a little bit of education in England, and lived in Asia for pretty much 20 years. So I was in Hong Kong for a very long time. So I was a bit naive. I sort of forgot what was going on in the rest of the world. But the maker movement is something that's come to my attention only in the last 4 or 5 years, and we've got these books. And then we have all these examples from MIT and also here SUTD, very locally, creating these fab labs, hacker labs, maker spaces, all these different names that they've got. So I want to talk a little about how the past and how the present and some other areas of the curriculum can sort of enhance the idea of the makerspace and the maker movement. And locally, we've had a lot of things, a lot of growth. I mean, the CEMNet conference a couple of years ago, 23 international makerspaces, most of them from the Southeast Asia, you know, spaces up in Chiang Mai coming to represent, big support from corporations as well. And one of the things at the bottom of ours is something that we started, really, the monthly meetup. It's still going now. People getting together, sharing ideas on a monthly basis to talk about, you know, what's the latest trends or all these different things. So that's supporting the maker movement in the local community. I was part of the NMC. I've just noticed that all my slides are actually slightly, anyway, not to worry. I was part of the NMC research a couple of years ago, and one of the things, if you've never looked at the NMC, it's an open source publication. It looks at how what is the latest trends in education. And one of the things that we looked at was the short term and sort of long term, and you'll see very quickly that the makerspace term came up. Things like 3D printing in there, cloud-based, and this is an annual report that comes out, but this is the first time it was sort of identified, the word makerspace, that people do see it as a tool that's going to be implemented in a lot of schools. Another one that's been sort of mentioned a little bit about this morning as well is the STEAM, STEM, steamer, hamster, all sorts of different terms. Again, I think science has dominated a lot of this, and I've seen some great success in schools. It's very, very, very popular in sort of junior school, lower school. I'm a middle high school teacher, but it's been very, very effective. And again, I think it's been around for a very, very long time. It's just that it's only had recently the big hype. And even university applications, they love this word STEAM on students' applications and how people have been involved. But personally, I still see schools doing it in separate ways and calling it STEM or STEAM. So I'm hoping that a lot of the things I'm sort of talking about are things that you've heard about and nothing new there. And design thinking, we spoke about design thinking this morning as well. Got this really nice graph that looks at how, you know, we spend the time to research, we then analyze the research, we then come up with some ideas, we generate a wide range of ideas. We then prototype, test things out, and then we evaluate, and that's wonderful, and we come to the end of it. And a lot of ideas here around products, services, and systems thinking as well. So design thinking, again, quite a recent big hype word in education. So what I want to do to you, I want to introduce you to design and technology education, which is what I'm trained in. I've been teaching it for 20 years. I've been in leadership role for about 16 of those years, and as I said, mainly Hong Kong and now in Singapore. And design and technology education is very English. It's a very English thing. It sort of started 25, 30 years ago, whereas in the US, things like shop were just called shop. And D&T has had a bit of a mixed reputation because some students, some parents see it as a very technical thing. So students are going to do technical learning, and they're going to learn a technical skill, and they're going to go into some kind of technical industry. And when I mean technical, I mean like carpentry or an engineer or those kind of things. So it's had both sides of the story. So I'm here really to talk to you about how a lot of the things that we're talking today about design thinking, maker education, are things that have actually been part of D&T for a long time, a long, long time. And I'm going to try and promote D&T a little bit as well and talk about the spaces. So D&T falls under, there's a variety of subjects that fall under D&T, and you will see very quickly that students have a huge choice. If they are really into systems, programming, coding, robotics, textiles manufacturing, interior design, architecture, mechanical engineering, electronics, all those kind of things, D&T has always taken the avenue of that. The national curriculum in the UK controls that, and it makes sure that teachers are running all of those things in a 5-year program. And you might go and do A-levels as well. Design thinking for us has always been the design process, okay? It's always been the design process. It's real. This is IDEO and Stanford D-School. Their design thinking is linear. Ours is iterative. It moves around. It goes back. You bounce in and out of things. And that's a very, very important, a very crucial part of design thinking, okay? That it is not linear. It is a holistic, iterative process. So just very quickly, how do you create a design process? You need to make sure that your projects are access and able students to be innovative, using design thinking as a strategy, allowing authentic designs, which I will talk about a little bit more, inclusive, ensuring that you are designing product system services for a wide range of users, including people with disabilities, okay, universally accepted. A wheelchair is a pretty harsh example of that. We want to have inclusive design that doesn't label people. Creative goals. We have a big thing on circular economy. Our school is doing a lot with the Ellen MacArthur Foundation, working with circular economy and working in design teams to create authentic problems. And the big important thing here is that we are, in DT, always working with clients. Okay, we're always working with clients, and it's authentic as best as possible. So just a little quick video. Oop. Just to give you an idea of our space. Is this going to play? So that's our makerspace, and obviously we had to put some really exciting words up there like laser cutters and CNC machines and 3D printers, because that's what parents sort of read in the media, and they find those buzzwords really exciting, and they're able to have those engaging conversations with the community, say, oh, my son is using a 3D printer at school. But the point is that a lot of those things are just tools. I mean, just like this complete conference, a lot of things out there are just, we just see them as tools. And if you really want to challenge learning, you've got to have the spaces to create those, and you've got to have a variety of tools. You can't just stick to one mindset and, for example, let's just teach robotics. The students still need to understand things like mechanical design and electronics and all those other things. So you do need to have some subject specialism that allows that to happen. Our students are very fortunate. We have a one-to-one laptop program. We use Autodesk. We are big friends with Autodesk Fusion. Students are able to use cloud-based CAD software free of charge, and they're able to do very exciting things around prototyping. A big part of it, obviously, in the design process is prototyping, allowing students to test things out. And this is just another tool. You can do it so many different ways, but we've got an example of their mechanical design. We've got PCB testing in the middle. We've got app testers, and the bottom one is a structural finite element analysis that allows you to test things in a controlled environment as well. So those are tools that we are using in DT education as well. And I know some of the maker spaces as well are pushing on this kind of thing. The difference is that we are doing this on a weekly basis. Students are locked into doing DT on a weekly basis, and also if they want to do it as a senior level program as well. Other things that we're doing is allowing students to manipulate, shape materials, learning that materials work in different ways, and using a range of tools again, traditional tools, power tools, to have a go at, and basically failing and learning from those experiences, very similar to some of the things that have been said this morning. Most of our projects are in groups. Design teams don't work individually. A designer does not work on their own. Okay, we work as collaborative teams. Each person's got a different role. Multidisciplinary teams enable students to engage in conversations and learn other skills that are not part of the academic world. And here are some examples of that as well, some design team work. And again, challenge-based learning. This particular example, very quick project that we do with grade 6. So these are 11-year-olds. All they have to do, the racetrack on the bottom right-hand side is a Pine Derby track. But students are challenged to make the fastest car, and again, they're working in teams. And if a student needs to 3D print an aerofoil that goes on the back of the car, they can just do that very quickly using CAD and using a 3D printer. But not every student's going to think like that. And we don't tell the students that you need to 3D print an aerofoil that make the car faster. They do their own research, and they find ways that will create their outcomes, and they've got a choice of how they do it. Big part of it as well is that we want students to be responsive designers and move away from this consumerism, design for consumerism. We want them to be socially responsive. We want them to have an impact on what they're learning, how they can use the design process, working with clients and finding out the real needs to actually come up with some projects that are going to have an impact. The bottom ones are quite big. They are not our students' examples, but we do have in the IB program, the senior program, we do have a few students who are looking at relief shelters and other things for design. So again, they're really interested in that. So, authentic design. At UWC, we're really interested in the process rather than the product. We are not a design technology department or a makerspace that creates beautiful products. If you ever come around to our space, you will notice that we have very few products on show. We have lots of models, lots of prototypes, lots of stuff all over the place, but we are challenging students to prototype. That's the main thing. Our main purpose is not to have a nice thing that you take home and celebrate with your family. It is more about the process. We heavily look at authentic design. We want students to be looking and seeing, for them to understand and then identify the problem, which will create their design brief. And we do this in a number of ways. We've also used these aging goggles, glasses, and arthritis gloves, so actually students understand what it feels like to be 60, 70, 80-year-old with muscle problems. So again, that authentic design, we try and get students to understand about empathy and designing for emotion. Big part as well, and you'll see a lot of this stuff in the makerspace, is using upcycled materials. We focus a lot of this, and we have after-school activities running as well that get an understanding of how we can keep the planet more sustainable. So these are some of the examples of words that we use, and we get students to understand that there is a big difference. And all of those things are hanging off our learner profile. This is a whole school learner profile. What's nice, I mean, the qualities are always very difficult to challenge students in. Skills is a bit easier, and we've spoken about the skills. But a good example is like commitment to care. If you're doing a service project and it's authentic, and we have a lot of service partners working for the aged, working for the underprivileged. If you are looking at the environmental part of it, then you're more a bit self-aware. What am I doing as an environmentalist? How can design? What are my decisions? So DT is one of those subjects that actually hits the qualities and the skills everywhere. Not many subjects can offer that. These are our spaces. Our spaces are multimedia. We don't have shop. We have a range of design studios and maker spaces all in one, with power tools, machines, laser cutters, and just to give you a quick idea, allowing students access to a range of resources. We have industrial machinery, CNC equipment. We have traditional welding, heat treatment areas, metal fabrication, and we have a huge stash of materials as well. So it enables students to get an idea of how to work with these and manipulate the materials as well. And I think, I mean, we're very fortunate. I'm very lucky to be in this college. We have a huge range of materials that gives students that flexibility. The big takeaway, I think, is that we are not telling students you are all working with plastic or you are all working with wood, which is a traditional approach. And we get students to be heavily involved in the whole school project again. So working with the client, the drama department's the client, who's the user, the students are the users in the production, what are some of the design briefs, the constraints, getting students to model, prototype first, then later on move to CAD, and then simulate. The bottom right hand is a simulation of the stage, including the revolving top hat for Alice in Wonderland, and actually getting them to design and make and assemble as an after-school activity as well. We invite experts. Remember before, the astronaut is an expert. He knows more about the moon than me teaching about it. So really important that we have regular input from experts from our community. And that brings me on to prototyping. Some of the things that we've sort of seen, and I'm also seeing these in some maker spaces as well. These are traditional sort of projects, you know, a desk tidy, a clock, a spice rack, a candle holder, and a spatula to flip your eggs. Some of you may remember these things. You might have done these kind of projects in the traditional DT approach. Some of you might have seen these things going on in maker spaces right now. they are not great examples of projects that we need right now. So this consumerism approach of designing products like this is something that we're trying to steer from. So the message here is that if you're designing those kind of projects, everyone's going to do the same thing. Everyone's going to make the same thing, go through the same stage, the same process. The teacher is very much in control. It's going to make it very, very easy. It's all about the product. And, you know, the teacher can guide the students very, very easily. So these are things that we don't want to see. We don't want to see. This is not real design, okay? And because you are running through a very linear approach, you are not giving the opportunity for students to actually learn anything. They might be very good at joining two pieces of wood together. 25 students are going to be very good at joining wood together, and that's all they'll know. But they won't actually understand why they're doing it or what's the reason behind it. So we're trying to get away from these product things, and I'm hoping that makerspaces also allow students to actually prototype and test and learn from the experiences to come up with some different design solutions than teacher-directed. So teacher-directed are obviously always in a comfort zone. If I'm teaching these projects, I can turn up at 8 o'clock and I can teach that project very, very easily. And if I have 10 classes doing that, it's going to make it very, very easy for my life. And for me as a teacher, that's going to be my comfort zone. For the students, it's going to be boredom. So we do try and get projects that are more design process rather than product, and allow students to be an authentic designer and come up with some different solutions to what's already out there. And that brings me on to the community lab, which is an idea I had about 3 years ago. 2013, I put a proposal into the board, and I said, what would be great is if we had some kind of makerspace. Let me give you a bit of background quickly. I'm running out of time. But makerspaces are a common thing in schools. Most common are in libraries, and they usually are, you know, it's great if it's a 3D printer and a textiles machine and some scissors and some glue. And that could be a makerspace, and that's completely fine. That's absolutely fine. But a lot of times it's an extension to the curriculum, okay? And I didn't really want to create an extension to the curriculum. And I didn't really want it to be part of DT neither. So the proposal I put in is to create a community lab, and this was sort of the goal about creating a community lab for the greater community, not just our school community. And this is very important. So our school is in the middle of, it's in Tampines near the airport, if you've come in on the airplane. We are not in a city CBD business district. We are in a housing district. There's a few software technology up there, but there's a community there that we want to reach out to as well and actually engage in the learning program. We want the community around us to understand that even though we're an international school, we are still a charity-based school. We're a foundation. We have 75 nationalities. Not all our children are from very privileged backgrounds. We have parents that struggle on all these different things. So about sharing some of the issues that we've got in that area. So this is what we created. We put in the community lab. This was the idea: collaborative space, creative space, purposeful space. And we hooked up with SL2, who are actually part of the One Maker group people who are also doing the things here. These guys are fantastic. They have a network of partners within Singapore, and these are the real makers. These guys are, they've got some fantastic range of ideas, and again, the partnership works both ways. They can also help us, because they're the experts in some things, and we can also help them. And just to give you some examples, here's the community lab. They're doing some, they are completely in charge of what they want to do. It's not part of the curriculum. At weekends, they have big makeathons, hackathons. They run after-school sessions. They work a completely different timetable to our school day. They're open till 10 o'clock at night. They're open Saturday and Sundays. Mondays, they're off. Okay, so it's a different kind of makerspace because it's in line with what the community needs. And it's nice to see slowly, this is only 2 months old, all right, it's only brand new. But it's nice to see we have engagement with the local Ministry of Education schools as well. Those guys are coming in and we're having some networking. So the community lab is a little bit different to a makerspace because it focuses on the needs of the community. 2 weeks ago we ran a program on food waste, very exciting weekend, and again looking at the real problems, the real issues in Singapore. What happens to food waste? What are some of the ideas that we can do? And getting students to engage in those activities. Lots of outreach, teaching students what to do in the local community, repairing things, collaborating on projects. These are weekly activities that the SL2 group run. And I think the takeaways I'm trying to, just to sum up very, very quickly. If we talk about makerspace, do we need large investment? No, we don't. The size of space obviously depends on what your criteria is, but you don't need to have specialist equipment. We're very fortunate that we have got CNC, CAD/CAM, 3D printers, range of materials, range of tools, and our community lab can access those things as well. But it's not about the type of space, I think, okay? Health and safety is crucial. You need to have people in there who understand machines and tools and processes and have actually got certified health and safety courses by a recognized institution. There are many technicians who support D&T or carpentry in schools that aren't certified. So make sure you've got that under quality control. Make sure that you, as the leader of that space, not running the space, you are engaged in some quality control and quality assurance to make sure that the learning program, the teaching style, and all those kind of things are what your vision is. And an example of that is you don't want teachers to be teaching students how to do the same thing over again times 25. Focus on product versus focused design thinking. Focus on process rather than product. Okay, get students to look at the different prototyping. And specialists is everybody. We've got students who are running fantastic workshops. We've got parents who are coming in who are specialists in entrepreneurships or setting up a startup or something like this. They are the experts, and like Paul was mentioned this morning, these are the guys that we really need to get engaged. So hopefully that's given you something to think about, and thank you very much.